demand functions. That is what we want to discuss and also see how to derive the consumer demand functions. So last time I mentioned briefly something about the consumer demand functions. Now the consumer demand functions give the optimal amount of each of the goods as a function of the prices and income faced by the consumer. The demand functions can be written as follows. Now for commodity 1, the demand function for commodity 1 is expressed as a function of the prices of the two commodities, that is P1 and P2, and the consumer income. M represents the consumer income. And for commodity 2, the quantity demanded is represented as a function of price of commodity 2 and the consumer income. When the consumer income changes, the optimal choices for the goods changes, yielding an income expansion path. So there is what we call an income expansion path, which simply traces the changes in the consumer demand as a result of the change in income. Now the income consumption path is also used to derive what we refer to as the angel curve. Now, on the other hand, when there is a change in the price, optimal choices also changes. So if the price of the commodities changes, the optimal changes, and this yields what we refer to as the price over curve, which is used to derive the demand curve. So we normally use the price over curve to derive the demand curve. And the price over curve simply shows what happens to the quantity demanded when the prices of the commodities changes. Now, the consumer demand functions are expressed as functions of prices and income. In our derivation, we must find functions of price and income. So each quantity of the commodity demanded is expressed as a function of the price and the income of the consumer. Now, the simple demand, okay, sorry. From this representation here, so we have the demand function for commodity 1 and the demand function for commodity 2. If you can remember how we used to express the utility functions. Now the consumer problem can be represented as follows. We have always said that the consumer always seeks to maximize utility subject to the consumer income. You will always seek to maximize utility subject to the budget constraint. Now, this is the utility function. Now, the consumer problem will be framed as follows. You maximize utility subject to budget constraint. Commodity 1 and 2 subject to the budget constraint. So this is the budget constraint. that the expenditure on the two goods must be equal to the income that the consumer has or less than the income. So actually, subject to the budget constraint. Now, that is a maximization problem we have. So from your mathematics, we can now introduce what we refer to as a Lagrangian multiplier, and then use the first. Now, if we introduce a Lagrangian multiplier, this is what we refer to as the Lagrangian multiplier. So this simply means that the Lagrangian multiplier is expressed as you introduce a lambda there into the budget constraint, which should be equal to 0. Now, this function we have here, we can now use the first order condition. The first order condition, we simply each commodity. So if we get the first derivative of the change in that Lagrangian over the change in the first commodity, this is what you get. You get the change in utility over the change in commodity 1 minus lambda 0. So you are simply getting the derivative. So you get the change in L over the change in what? Commodity 1. So this should be equal to what you have in the next page. The change in utility over the change in commodity 1. Now you do the same, the second commodity. So you get over the change in commodity 2 minus lambda price 2. So this would be equal to 0. So you also find the derivative of change in the Lagrangian multiplier by the change in lambda. So this should give you to the budget constraint, which should be equal to 0. Now you have used the first order conditions. Now the next step is to rewrite equation 4 and 5 and dividing them. So if you divide these equations, so you divide this equation and this one, simply get the ratio. Divide this with this. The change in utility over the change in commodity 1, divide the change in utility over commodity 2 would equal to the price of commodity 1 over the price of commodity 2. So in simple terms, that means that the marginal utility of commodity 1 over the marginal utility of commodity 2 should be equal to the ratio of the prices of the two commodities, which is P1 over P2. So this was that. Then we need to proceed now. So remember, we had discussed the consumer equilibrium area. Now what we see in consumer equilibrium, Now, this is similar to the consumer equilibrium that we had discussed earlier, so which corresponds to a point of tangency between an indifference curve and the budget line. From the graphical approach we discussed earlier, so we said that the slope of the budget line and the slope of the indifference curve are equal at the point where tangent to the indifference curve. So equivalent to what we have here, that is the marginal utility of is equal to the price of commodity 1 marginal utility of commodity 1 would be equal to the price of commodity 1 times the marginal utility of commodity 2. Now, if we solve the equations 3, 4, and 5 simultaneously, we obtain the demand functions and the optimal choice bundles. Now, we can use an illustration here. Let's use the consumer preference given as a Cobb-Douglas demand preference. Now, assume the utility function or the consumer preference is given as a Cobb-Douglas function. That is the utility, which is a function of commodity 1 and commodity 2, is given as x1 raised to alpha, x2 raised to beta. Now we need to formulate the consumer demand, sorry, the consumer problem. So I said that the consumer problem here is simply maximizing utility subject to the consumer constraint or to the budget constraint. Is utility subject to the budget constraint. So the utility is given here as a Cobb-Douglas function. Now, we maximize utility subject to the budget constraint. This is the budget, and in this case, consuming, that is x1 and produce our Lagrange. This is what you get. So from that Lagrangian multiplier, use the first order conditions. We simply find the derivative to each commodity. So if you find the derivative, so find the change, that is the change in that Lagrangian over the change in x1. So this is what we'll get. First order condition with respect to commodity 1, you get this equation. Then you also get the first order condition for commodity 2. So you also get this function or equation. Then you also do that with respect to lambda. This gives you the budget constraint, which you equate it to 0. Then you proceed and rewrite and divide equation 1 and 2. So if we do that, simply divide equation 1 and 2. So if you divide 1 and 2, that should be alpha x1 raised to alpha minus 1 x2 beta divided by beta x1 raised to alpha x2 beta minus 1 lambda p1 lambda p2. To cancel out, you have done indices and the surds. So if you cancel out, the final solution that you get is this. And this is what you get. Alpha x2 over beta x1 equal to the price of good 1 over the price of good 2. Now from here, you need to make x1 the subject and also you make x2 subject. So this is critical from this point to note. So once you have done that, make x1 and x2 the subject, one at a time. So if you make x2 the subject, then it will be p1 times x1 over p2 that is x2. x1 will also be alpha over beta p2 x2 over p1. That's what you get when made x1 and x2 the subject. Now from this step, we need to go back to our budget constraint. We replace x1 and x2 in our budget constraint, one at a time. So the budget constraint, we go back. Now, this is our constraint. Now we can substitute x1 or x2 into the budget constraint, one at a time. So we have found that our x2 is equal to what? This is our x2. This is our x2. So we can replace this in the budget constraint here. And then find the optimal bundle for commodity 1, which is x1. So this one will cancel this, and then you find this is what you'll have. This is what you'll have. So you'll have P1 x1 beta over alpha P1 x1. So you can factor out P1 would be equal to what? M divided by 1 plus beta over alpha P1. Now that means from this point you have your x1. You need to take a look at that. X1 is made up of M divided by what? P1, which is multiplied by 1. 1 is a function of what? P1 and income, which is M. X1, which is now optimal, is made up of this. This is consumption of commodity 1. Now we also do the same to commodity what? 2, that is X2. Can go back, replace again X2. Now instead of X1 here, we now replace it with what X1 is from our function. So X1 is equal to this function here. So take it back, replace it in the constant, replace it here. So your X2 would be equal to P over alpha plus beta M divided by what? P2. Now this is our optimal demand functions that we are talking about. But the optimal demand function, we said earlier that it is a function of the price. So the X1 star and X2 star are referred the demand functions that represent the optimal choice bundle. So they provide the solution to the consumer utility maximizing problem. The X1 star, X2 star is what provides the consumer utility maximizing problem. We need to understand how to derive those consumer demand functions. It's important. The motor agnostic. So if I take you back again, so if we have a utility function, which is the Cobb-Douglas utility function, like this one here. So the first step is simply to formulate the consumer problem. And the consumer problem is derived as a utility maximizing problem subject to the budget constraint. This part here simply shows the consumer problem where utility is maximized subject to the budget constraint. So once you have formed the consumer problem, the next step is simply to introduce a Lagrangian multiplier. This is the so once you have introduced the Lagrangian multiplier, now you use the first order conditions with respect to each commodity. So find the derivative, the first derivative of the Lagrangian multiplier with respect to each commodity. So for commodity 1, this is what you have as for the first derivative with respect to commodity 1. Then you get the first derivative with respect to the second commodity. That is what you have. And then you do or you get the first derivative with respect to. Now from there, just divide equation 1 with equation 2. Divide equation 1 with equation 2. So if you do that, this is what you get. Dividing equation 1 with equation 2 gives you this. So if you simplify, simplifying that, you get this. This is what you get if you simplify that. So from that point, then make x1 and x2 the subject one at a time. So you have made x2 the subject here. You have also made x1 the subject. Back to the budget constraint. Replace x1 with this, and also replace x2 with this one at a time. So if we replace x2 in our budget constraint, this is what you have. So we have p1x1 plus p2x2, but in place of x2, we use this. So x2 is given as p1 over p2 times beta over alpha x1. So we take it here. This is what we have replaced it here. So you can now solve and get the common terms together. This is what you have once you have done that. So you can factor out p1 x1, which gives you this once you have factored out. But making x1 the subject, you get x1 is given as m divided by 1 plus beta over alpha multiplied by what? The price. Now this is our optimal demand function. Also do the same commodity 2. So you can get the demand function for commodity 2, and in this case, we need to replace x1, our budget constraint. So x1 is given here. This is x1. Go to again here. So in place of x1, you replace it with what we have here. So our 2 would be equal to beta over alpha plus beta over multiplied by m over p2. Now this is what we refer to as the consumer demand functions, and they give the quantity demanded function of the price and income. Now, given the market prices and the income level for a consumer, then the functions describe the exact amount of both goods that the consumer could have to consume so as to maximize utility. Income of the price, those two commodities. So find the exact amount of each commodity that the consumer needs to consume to maximize the utility. So we can do this from the consumer demand functions that we have discussed. Now this part is very important. You need to understand how to derive the consumer demand functions. Now, once we have done that, we have derived the consumer demand functions. Now, when the income of the consumer changes, as I mentioned earlier, the optimal bundle also changes. If the consumer income changes, then optimal consumption bundle also changes. Similarly, if the prices of the commodities changes, so the optimal demand function will also change. And when the income changes, or price of the two commodities changes, we will have what we refer to as the income and substitution effect. So that is what we want to analyze. When the price of a good changes, there are two types that may occur. Now, the rate at which one can exchange one good for another changes, and the total purchasing power of income will also change. Now, these two causes changes in the consumer demand for the two goods. Now, the rate at which one can exchange one for the other will change, and also the total purchasing power of the income will change. Now, this will automatically affect more consumption bundle. Now, the change in demand as a result of the change in the rate of exchange between the goods is called the substitution effect. We call the substitution effect. Now, the change in demand, the change in the purchasing power is what we refer to as income effect. So we need to understand the substitution effect and the income effect. Now, the substitution effect occurs as a result of the change in the rate of exchange between the two goods. So if the rate at which we exchange one good for the other changes, then we have a substitution effect. And when the purchasing power changes, then we have the income effect. We have an income effect. So we can consider each separately. We can discuss the substitution effect. Then we can also talk about the income effect. Now, we can effect, and I said the substitution effect capture the effect, let the relative prices to change due to a price change, and we also adjust the money income so as to hold the purchasing power constant. Now, if the relative price change, so what will happen? So we have the budget constraints. So we have the budget line, but we have three budget lines, if you can see. So the first one, which pivots the outside or towards the outside one. Then we have the pivoted budget line. This is the original budget line, which by 4 we have the pivoted budget line here. Then there is a shift in the budget line. So you can see this one, this shifts outward. There's a shift in the budget line, and there is also a pivot in the budget line. So we need to distinguish that. Now, if the price of wood 1 falls, assume that the price of wood 1 falls, means that the budget line rotates around the vertical intercept, that is M over P2, and it becomes flatter. So if the price of wood 1 changes, this is now the intercept we are talking about. So there will be a pivot. There will be a pivot. So there will be a pivot for that budget line. It is simply pivot. Of wood 1 falls, the budget line simply rotates around the vertical intercept. So this is the vertical intercept, and it becomes flatter. Now this movement of the budget line, we can break it into 2 steps. And the first step is where the budget line pivots around the original demand bundles. Once it pivots, then it shifts out to the new demand bundle. Now, so I've said the first step is the budget line simply pivots. We have the pivots to this point here. This is now the pivot. Then from there, it simply shifts outward to a new budget. So we have the final budget line, which is simply a shift of the pivot budget. Now the pivot is simply movement where the slope of the budget line changes while its purchasing power remains constant. And a shift is simply a movement where the slope of the budget line remains constant and the purchasing power changes. Now, once the budget line pivots, a change in the slope, which means it's a change in the rate at which one wood is exchanged for the other. So in simple terms, when we have a substitution effect, the budget line simply pivots. And when we have an income effect, the budget line simply shifts outwards or inwards. Like in this case, the budget line has shifted outwards because of the change in the purchasing power